Continuing with the platform game, so now that we have platforms and Unicorn can bounce up and run and jump on to the different platforms, what we want to be able to do is to have a larger world, because it's hard to make artwork small enough if we're confined to just a single size stage. So it'd be nice to be able to design entire levels that are big enough that we can be scrolling across the screen, and the level size is based on how big you want to make your project. So to do that, moving on into P9 camera, a few more things have been added. Now when this runs, we'll notice that it looks a little bit different, that the unicorn disappeared, because while developing this, I decided not to have it set up with the unicorn, just to cut out extra code to keep it a little bit cleaner. The background image is so that we can see the image is scrolling, and it's 3 images wide. So the background is big. Now as I move, we can see how it's also taller than our 800 by 600. So this entire image is bigger than the 8 by 6. This image is 1024 by 768 in size, so that's why it's a little bit taller. So we get a little bit of vertical scrolling with the camera, and then it's larger than the 800 wide, and then I stacked 3 of them side by side to create a larger world. Now, if you are building the graphics for your own project, you could make a seamless background that is scrollable, or you could build one large graphic that is the size of your level, so that you have one completed picture that is your whole level, that makes it interesting and engaging for the player. So that's the gist of what's going on with that. We have the unicorn, we have the platforms. The unicorn just got simplified a little bit. I removed the images so that we could instead worry about displaying it on screen. So far, there's very little change in the unicorn. There's a couple things that have changed that we will look at, but it mostly has to do with how the player is moving, and then checking for some boundaries that we'll have to worry about how to do that. And we're able to combine, if you notice, check boundaries disappeared because we have something going on here that will be explained in a little bit. 2 new classes appeared. We have the frame object and image object. So as part of the setting up the background, we could just draw the image, but it's better to have this image being drawn as a class object, so it has properties that we can work with, because when we have this object on screen, then when we move into our draw, we're able to tell that image to display itself. So we have an image object. The image object has X, Y, width, and height, and it has an image property of what image that is being displayed as part of that. Now, for the display option, this is how the image gets repeated 3 times, is I just used the image command, drew it once, drew it again, using the width of the object, pushing it over 1, and then push it over 2 more, so that's how it draws all 3 pictures of Aaron across the screen. If you have a single large graphic that you are using for your background, you would just have one single image command. But it's necessary, these image objects and the frames that we'll look at in a little bit, they're very similar, X, Y, width, and height. The frame object is so that we're able to construct and store this information, because we need to know how big is the camera that we're working with on screen, and we need to know how big is our entire game world. So those entities are stored in a frame object instance. So the back image is the background image that gets put on screen. It's non-interactive. That's why under an image object, all it does is have a display. It doesn't have an update because there is nothing to update. You could, I suppose, you could make something that was more complex. It maybe would use multiple layers of images, so then you could have different things moving at different rates and other layers of images built into it. That's certainly possible. But for our example purposes right now, I'm just drawing the image across the screen. Frame object, as you can see, just has X, Y, width, and height. This gives us a way to store information, because to do the camera, we need to know how big is our game world, and then I need to know what is the view that the camera can see. And the camera is set to the width and height of my project. So we can see how my project is 800 by 600, so it's setting those values there. So it's using the full height of the project. So that's why the camera moves with everything moving on screen. The game world is 3 times the size of my background image. Now, I didn't hard-code numbers in, but I certainly could have hard-coded numbers in, so I could have set this up at 3072 if I wanted for the width, and then the height I could have put in 768, and then put in 800 and 600 for the width and height for my camera object. So I could have hard-coded numbers in versus using these relative ones. So that's kind of a moot point as you're figuring that out. You can see the background image. When it was put in, I put in the image specs of 1024-768, and then the name of the image file that we are referencing. And that is the image file that gets loaded with our load image command. And then that JPEG needs to reside inside our data folder. So with storing this information, so this frame object is really just a way to store that data. So game world has an XY width and height, camera has an XY width and height. I could have just made 8 variables for those and just done it that way as well, and that would be okay. I just didn't want to do it that way. I thought it made more sense to store that into this object capacity. Now, the next thing that happens is the camera gets its X and Y centered on screen. So what we do is we add together the game world's X, which starts out at 0, and then we add half of the game world's width, so that now finds the center of the screen, and then we subtract back half of the camera's width. So now the camera is centered, because remember, the camera isn't drawing from its middle. The camera draws from its origin point, top left corner. So that's why we move back to the top left corner of the camera with these 2 lines here. So this now makes the camera, when the camera's on screen, so the camera's X and Y is this little corner right here, which is not the far left corner of my whole thing, because the left is over there, but as you can see, X and Y, or the Y is not. So now we're able to move that camera over. Creating the unicorn and platforms, nothing changed there. When we move into draw, the key difference that is happening here is that all of our updates need to happen first before we call display for anything. So I update the unicorn. I'm going to update the camera's position, and then I'm going to verify that the camera is going to stay within the game world boundaries, so that if the camera's X is less than the game world's X, camera X is set to the game world's X. Same thing with the Y. But now if the camera's x plus its width is greater than the game world's x plus the game world's width, then it pulls it back on screen to make sure it stays where it needs to stay. So these lines here are checking the left, right, top, and bottom of the camera to make sure that the camera does not go out of bounds. Then the magic that we've been waiting for, which is we move 0, 0 to, as we can see, we translate to the negative camera x, negative camera y, so that we move, then display the background image, display the unicorn, and display the platforms. So effectively what we're doing is we're making 0, 0 become the camera's origin area so that it moves and keeps the camera centered on the player. But then the player, once the camera gets maxed out, the player is still able to move off of the center, so we're not completely locked, because otherwise when the game is running, right now, if the camera was always centered on the player, I would not have been able to move without the background and platforms moving. We would have to shift things over even more, and then that would show us effectively out of bounds. Now this having a kind of camera that moves with or stays, now at this point you notice that the camera is effectively centered on the player. There's been a lot of development and strategies, if you go back and look through the history of video games, of how do we keep a camera moving with the player as they move throughout a game world. Do we keep the camera permanently centered on the player, which is a strategy that a lot of games did. Other strategies are you can move within the screen, but you never get to leave the screen, which is what our platform game was doing before we added in the camera. And some have an active area that you can move, but then once you get towards the edge of the world, then you are able to move beyond the limits and the camera stays fixed and you can move until the player hits the boundary. So there's been a lot of different strategies and pros and cons of, well, what is the best way to do it or how should you do it? And you can go and study classic video games and see which way or means or style appeals to what you want in your particular project. So what we're looking at here is one system. The camera stays centered within reason until the camera has maxed out towards the game boundaries. Then the player is able to move until they themselves hit the game boundaries as well. Putting this into your project, couple things to notice here. Okay, so we're displaying the unicorn, we're displaying the platforms. If I go back into the platform code, nothing changed. If I go into the unicorn code, well, I modified it a little bit, but it's pretty much nothing changed. So the real difference that's happening is we update the elements within the project. Once those elements are updated, then we translate our camera so that we're translating the point at which we want to draw the object so that they will always stay on screen. And then once we do that, we're able to draw the background image, draw the unicorn, draw the platforms on screen. Now I do have the push and pop matrix just because anytime I'm doing translations or transformations of elements, I always do that so that I know that it's a self-contained unit. Because now this display position data information, which right now nothing was really going on, but if I had that here, we can see the text is showing up on screen up at the top. And it's always fixed no matter how the camera is moving, because this push and pop is isolating this translation. But if we remove those, I don't. So now we can see it's drawing it permanently on my screen up here. So it's only drawing it at 50-50. So it's now keeping it. It's moving along with everything else. But if I want that to remain separate, so that if I'm drawing a score, a health bar, putting a game title, making my whole kind of game chrome, as it would be called, that framing, I want that to be separate. So this between push and pop is containing the information that we need for moving the game elements with the camera. So push matrix says store the current information. So then when I translate and then draw these things based on that translation, once I get to pop, I can go back to the original layout information. So that isolates this transformation here, so that then display position data doesn't move. Previous example of working with the platforms, we moved the player using x plus equals vx, y plus equals vy, and then we had to call check boundaries to keep the player on screen. Well, we can do that in what would be kind of a more efficient manner. So now with our camera, we set up. So move, move, move. And now if we look what's happening, part of it is this simplified things a little bit under the boundaries. So this limits the movement within the boundaries, but it did also remove bounds, which we will be adding back in the next version in P10 in a moment. But if I look at this, x is equal to the maximum value of 0 or the minimum value of x plus vx, or the game world minus the width of the unicorn. So this one line here is effectively checking boundaries and adding in vx. So it limits it so that vx will not allow me to move out of bounds, because what math and max and math min do, when I use max, it says take either 0 or this number, whichever is bigger. Now when I look at min, it says take either this number, x plus vx, or game world width minus the width of the unicorn, whichever number is smaller. So it adds in vx as long as vx is smaller than the width of the world minus the width of the unicorn. So that effectively created a boundary check without having to check boundaries, which is kind of cool. And then the y works in the same way, where it uses height instead of width. So this is kind of a one-line version of x plus equals vx, and then checking left and right boundaries. Now we will have to do some of that when we bring back in the artwork and bounce and all those things, and we'll see that in Project 10. So the unicorn had that subtle change, but then that will be incorporated in more detail in the coming pieces. Platform didn't change. We have the image object for drawing the background image. We have the frame object for storing an XY width and height for a rectangle object. And then we're using the matrix transformation and using translate to adjust to the camera's position so that we're able to stay centered on screen. And in doing that, we now have a camera that follows the player as it moves around in our project. Moving on to the next step, going back into the platforms. So P9 camera platforms, apparently I have two P9s, which I realize now. I'm like, oops, that's a goof there. But anyway, this one now actually brings the unicorn artwork back into it. The first one with the P9 camera was to figure out how to get the camera moving. So this is, everything is going to be the same here except inside of the unicorn part, because otherwise nothing else is changed. So the main code doesn't change. Frame, object, image, object, platform, they're all the same. The unicorn is the only thing that's changing because the unicorn needs to be able to update its graphic based on which direction it's pointing. So now it's still using the math min, math max options for setting up boundaries, but then under the check boundaries now that is modified. So check boundaries is now brought back in to allow us to do our bouncing. And then it's, if we notice here, it is setting. So when we hit left, it sets it to 0. Game rolled with. So it's doing some of those boundary checking. We don't need, under check boundaries, it really should just be we're checking to see should we bounce when we hit the walls. So I don't actually need to be setting the limits on it because limits for the position are set here inside of the update. So with that, we don't need to, under checking the boundaries, we're not really having to check or reset our position, but we're using this to find out if we have hit the wall, then we need to bounce. Now, if you don't want bounce going on as part of it, then we don't really need any of the boundary information. I do like the bounce when it lands on a platform or the ground. So that's where having some of this information is useful. But as far as left and right, if you don't want to bounce when you hit the left and right sides, you can just eliminate that out of your code, and then that would be no harm, no foul, and then that would take care of that. So the only difference between this and the previous P9 camera and P9 camera platforms is this one now uses the animated unicorn, so then we care about facing right, and it brings back bounce and gravity into it. And part of the reason for eliminating that in the previous version was to solve one problem at a time. Solve the camera first, and then bring back in gravity, bring back in animations to keep the code simpler when we're looking at it, to try and figure out if something's not working, how do I get that one thing to work first? So that was why I eliminated things from an already working project to simplify it, to solve one problem, and then I brought those elements back in to get it working. So now we can see that it's working. I can jump up. Gravity is back in the game. Now you will notice the platforms are badly placed, that once we get on the ground, we're kind of stuck. There is, I guess, one other thing that is happening inside of the draw function is it's checking to find out if we've landed on a platform that has a different kind of type, then it's going to change the color of the unicorn. So it's changing the unicorn's color as part of that. So it's landing on a platform that has the type of death. And this process of figuring out good versus bad platforms is going to be modified in some of the upcoming examples further as well. But that's why the unicorn, when the project runs, he's perfectly fine here, but then when he hits the ground, it's now stuck and turns red. And there's nothing that would, once he's turned red, there's nothing to turn him back. That's why he stays red at that point. Moving into the next phase of adding in enemies, because moving around the world is fine unless the world has hazards in it, so then you're worried about dying, then that could be your entire game. So the world itself is your enemy. But if we have actual entities or enemies moving around on the screen, then that could be another way that we want to create excitement and engagement for our player. So the enemy is, if we look here, it was a copied version of the unicorn, and then things just got modified. We have different varieties going on here. As you can see, I didn't delete things. I just commented stuff out that we really didn't need. Looks facing right. We don't really need that because when it's updating or moving, it's not really facing left or right. Now, as I look through what is happening here with the enemy, so again, this was the unicorn, and all it did was get modified to be the enemy, and there's no artwork yet, so it's just drawing a yellow box. So if I hit run, we'll see that it draws enemies. The enemies don't interact with the player yet. You'll also notice that the enemies are staying nicely on their platforms. And we'll figure that out in just a moment. So the enemies are the same way we add groups of elements. We create an array, populate that array with a bunch of new enemies. But if you'll notice, each enemy is being passed to it a platform. And that is how the enemy knows. So when the enemy is created, it receives that platform, so it knows where to put itself on screen, and it also knows how to establish its left and right edges, so it knows where it can move, and then it knows what its Y is based on the ground and where it's at. Now we'll be using some of these other things of acceleration and gravity and all that. We'll be applying that to the enemies in a little bit when we have collisions, because then when they collide or die, then they're going to jump up in the air and then fall down because, well, that's just fun. But the each enemy needs to know where is it being put on screen, and it needs to know where its boundaries are, and that is based on a platform. So when we create an enemy, we send to it a platform. Because I could pass in information. I could pass in X, Y, and the width of the platform right here. So I could just pass those three values in. But it's just as easy to pass in one of my platforms. So when I put an enemy on screen, I'm just passing in a platform to pass in these values. But the enemy, it could be written instead of a platform, I could write it as float platform X, float platform Y, float platform width. So I could pass in three values, but we already know that the platform has X, Y, width, and height. So it just seemed easier to just pass in the platform I want to put this enemy on so that the enemy's moving on the platform. So currently, enemies receive a platform so that I don't have to worry about if I change a platform's information, the enemy's not going to be in the right position. So I just pass in a platform that I want the enemy to appear on. That enemy uses that information to figure out where to go on screen. So it sets its X equal to the platform's X plus half of the platform's width minus half of the enemy's width. So that starts each enemy centered on its respective platform. I don't have to start them on the center. I just think it looks nice. But you could start them wherever you want as long as you put them on the platform. Because if they're not on the platform, they will fall. Because they are affected by gravity. So we need to keep them on screen. Because we can see their Y is affected by gravity. Because if we were to start them up just a little bit, actually I think, or do they start up? Oh yeah, because they start up and then they fall onto their platform. So they're starting up in the air. So the left edge and the right edge and the ground. This is so we can make reference of, are we on the ground? Left edge, so we have, this would be the left boundary, right boundary of how we want the enemy to be able to move. The ground is the part they're standing on. Now their starting x velocity is going to either be -1 or 1. And the way that works is say, give me a random number out of 10. And if the random number out of 10 is less than 5, my Vx is -1. Otherwise, my Vx is going to be 1. So this way of organizing something, which is we're asking the question of if my condition is true, do the first thing, otherwise do the second. And this concept is referred to the ternary operator. It's not critical to memorize or know that vocabulary word, but this is a shorthand way of writing a if-else statement. So we say, if this condition is true, question mark, we're asking that question. If this condition is true, question mark, do this first thing, otherwise we put a colon, and then we say do the other thing if it's false. So it's a one statement. If you have a real basic thing like this where I want it to just be one number or a different number, it looks much nicer writing it this way instead of writing it as Vx is equal to, or we would say if random 10 is less than 5, Vx is equal to -1, else Vx is equal to 1. So this one line of code is the same as this full if-else statement. Now, if you want to write it out with the full if-else statement because that makes sense for you, go for it. Know that this is a common programming way of writing a basic if-else line of code. This is common in most major programming languages, that you can write it this way. It's entirely up to you as to how you want to go about doing it. So that determines whether the enemy goes left or right when it starts. The enemy is affected by gravity. Currently, the enemy doesn't have a frame sequence or anything because it's just a big yellow box. I'll leave it up to you to put in an animated sequence for your enemies if you want. You can determine if the enemies face left and right. Maybe they're just a blob of slime that moves across and oozes, and it doesn't really have a left or right. It's just oozing. It's up to you. You can figure it out. It's using similar, again, everything's pretty much the same in terms of, moving. Just check boundaries, it bounces when it hits the ground, and it uses ground to determine, so that it's able to bounce when it hits the platform. So this ground value is that y value we want it to land on and stop at, because that y value was set as the y value of the platform. So when we run it, Some go left, some go right. They bounce and then they're moving. But there's no collisions yet. We can't knock them off their platform. They can't do anything else. They can't do what will become their death jump that they will do in the next iteration. Moving into the enemy collisions, there's a few more things going on here. As I look through this project, I'll see that if I run into them, they jump up in the air when they get hit, and then they fall down. And eventually, once they fall down, they land on the ground. You can see they bounce when they hit the ground. When I hit the ground, the background starts strobing with this, death color that we're all going to die, the world's going to end, etc. We can see it, the unicorn turns bright red, and the background, flashy red. So what we're going to look at here is, and I also have a little health bar that as I'm either on the ground or hitting the enemies, my health goes down. We can see health is continuing to go down. IOG is on ground, true, and CS is collision side, none. So we can see that when I'm on these platforms, it registers bottom there. Even though we had a collision side occur, it didn't occur there. And those points are going to become important as we walk through the code and understand. So what I did is I put text on screen here as a way to understand what is the program thinking. If you also notice with this black bar, I can't cross the unicorn into it. The green box, the rectangle that is my artwork, stops when it hits that bar. That is now the ceiling for my game. So I modified the size of the camera to make the camera smaller. So the camera, if I look at what is happening here, that my camera is now 100 pixels short. So that shift in the camera size is to adjust the position of the camera so that it's smaller, so that I can have that bar across the top where I want to put my kind of game information, and also put some text on screen. So enemies, nothing changed there. If I look in enemies, nothing changed. So the change that's happening is occurring that there is now a new rectangle collision function, player versus enemy. So we pass in the unicorn and the enemy, and we set their distance x and y apart. We combine their widths and heights, or their half width, half heights, and then we do that comparison. So if the absolute distance of their x is less than the combined half widths, they're overlapping on the x-axis. So then you check the y-axis, and if both of those are checking out, collisions happen, so we return true. If both of those haven't happened, that means we never get to this line of code. We return false. So this function returns the Boolean value of true or false, rectangle collision with the player versus enemy. Now if we go back into our program, we can see that we check collisions with platforms. If the platform is of type death, then our health goes down. Now, we're also having this little P health and health. We'll come back to that in a little bit, but that's how we change the color of the unicorn when the unicorn is on a bad platform. In this case, that would be the ground. Now, cycling through the enemies, we tell an enemy to update. Then we check to see if the enemy has collided with the player. So we pass in the unicorn, we pass in an enemy, and we make sure that that particular enemy is not dead yet. And if the enemy is not dead yet, then we tell the enemy to run its death jump function, and we take 20 away from the player's health. Now the enemy's death jump function uses jump force, which we had before. Kills our x velocity, so it just goes straight up, so it's not still moving sideways when it gets hit. It sets a Boolean value of dead to true, and it now changes the ground that the thing is aiming for from the platform to the bottom of the game world, so that it lands down at the bottom. So that's what death jump does. Now if we go back up under properties, we'll see that in the beginning we're not dead yet. Dead is false. But then when we get hit and call death jump, then the enemy gets whacked. So now enemies can update. If the enemy's not dead, it can collide with the player. So if it does collide with the player, it jumps and we lose health. So that's how we deal with the collision with player versus enemy. Now this whole P health, which is previous health versus health. So if my previous health is greater than my current health, that means my health has gone down. And when that's occurred, we change the player color where we're going to tint it red. Otherwise, we tint it with white. If we tint a color with white, it lets the color just be the color. But if we tint it with red, then our player is going to be tinted red. Now, if I look in the unicorn under its display, we will see that it applies a tint value, and this tint value is C. Now, tint, as we look at it in processing, in the reference on processing, we'll see if we take an image and we apply a tint, it tints it with that particular color value. Tinting it with white then applies no tint to it. Once we apply a tint value, it's going to keep applying that tint value until we set the tint value back to white, or we reach the end of the draw loop and get to start over. So that is how tint works. So it's much like our transformations of translate and rotate, that they reset in the draw loop, but they will stay in effect until we kind of undo them. And we undo it by using, in this case, we would tint it with white to undo it. So we tint it with 255 or white, which then removes any tint value. We'll see that tint takes any number of values, so we can use RGB, RGB alpha, or value 1, 2, and 3, where that's the red value, the blue value, or red, green, and blue values, or red, green, blue, and alpha value as well. So we can apply tint to our colors. So looking at the tint here, we apply tint every time. It's just tint is either going to be white, or if our health is now less than it was in the previous frame, then we tint it red to kind of show that, ooh, we're in trouble. And then at the beginning of the frame, then we set our previous health equal to the beginning of draw. We set previous health equal to health, and then we start the process over. So 60 times a second, it's updating it. So if it's going to be somewhere happening long enough, then we get to see the magic happen. So when I land on this, we can see now it's tinted red. The strobing effect is something else. We'll take a look at that as I work my way through. So we strobe the background. So if the unicorn Y is now, its Y is equal to the platform 0, and if I go back up to the top, we'll see platform 0 just happens to be the ground, and it has a death value associated with it. So when I'm on the ground, I'm going to create a fill color that is red, no green, no blue, and it has an alpha value of A times 8. Now what we don't know is what was A, because I haven't talked about it before, but A in this instance is being short for alpha. So it's an alpha value, because red, green, blue, alpha. And A started out at 0. So A starts out at 0. So it's A times 8. That would be 0 times 8. That's 0. And then we say A is going to be equal to A plus 1. And then the math modulus operation So we divide it by 20 and then keep the remainder. So what that means is we're going to get numbers out of this line of code here of 0 through 19. 0, 1, 2, 3, 4, because A starts out at 0, and then 0 plus 1 is 1. 1 divided by 20 is 0, remainder 1, so we keep the 1. Now, A is equal to 1. 1 plus 1 is 2. 2 divided by 20 is going to be 0, remainder of 2. We keep the 2. Then we go all the way up. We get up to 20, because when A is 19, 19 plus 1 is 20. 20 divided by 20 is 1, remainder 0. But we don't care about the 1, we care about the remainder, so we are back to 0. So the way the modulus math operation works is it will keep doing that infinite counting loop. In this case, 0 through 19. Because our cap here is, it gives me a loop of numbers that are less than 20. We were using this in the unicorn to cycle through the frames, because then we're dividing it by the frame sequence. Frame sequence is 6. So current frame started out at 0. 0 plus 1 is 1 divided by 6 is 0, remainder 1. And then so we already were using this previously. It's a really easy way to do a loop. And that's what we're able to do right here, is we can now create this loop that does 0 through 19, and then we can figure out the math, or 20 of by 8. 8 times 20 would be 160. So it's 152 through. So it's 0 through 152 alpha. Well, 128 alpha is 50% transparent. So we're creating this cycle where it will cycle all the way up. And that's how it creates that kind of building red flashing background when the player is on the ground. So now we see this where it builds, so it gives that little kind of flashing strobe effect with the red. So originally, when I set it up, I was going to use a timer for it. I set up a strobe timer, and then I was going to figure out is the strobe on or off, and when it's on, then we'd tell it to run, and it was like that. It was getting more complex trying to write the timer into it than I wanted it to be. And I was like, okay, this is adding way more mess into the whole thing. It got messy, and I decided I don't need a timer to pull this off. We just need to know that when the player is on the ground, then we start rotating A through, and we display that strobing background into the project. And that was really it. Now, currently it had some other stuff in here. You can see that I was going to set up so if my health goes less than 0, I was going to do a bunch of other, and that's all just commented out, and I never got around to figuring out what happens when your health goes below 0. It's going to just, it was supposed to be something, and then that was messy with the timer, so that's where it kind of like, screw that. But I never got around to sanitizing the code and removing that stuff from it. Most likely, if our health peak goes below 0, this is where you would change where you do game state equals lose or die, or something depending on how you've configured your game states. So most likely that's how we would configure that one. But there's no game states in this platform example yet, so you'll have to figure out how to incorporate that yourself. Working with the final stage in this go around is adding in the bullets, so that we're able to shoot at the enemies. So with this, I have an array of bullets. In this case, I think it's 50 or 100 bullets that I can shoot. 100 bullets. So that means you can really shoot. And the firing timer is set pretty quick, so I can fire fairly rapidly. If I hit, but if I hit a land on him, I lose health. But if I shoot him, and now you will notice that I turned red. This platform also had its platform type changed to death. Therefore, it's now affecting my health. So if we have a bad platform, we can use that as part of it. Now we can see the health is going down. And there's a bunch of other information up here that we'll talk through in just a little bit. So, 100 bullets. And we start out and figure out which is the next bullet we're going to work with. So we make all 100 bullets to start the project. Firing timer currently set to 50 milliseconds. That's pretty quick. If we say slow that down and do 200 milliseconds, that means I can do 5 bullets per second, but now it's not quite as egregious. And maybe that's even a little bit too fast, as we could slow it down even more and do like half a second per shot. So the firing timer controls the frequency of when we're able to shoot the bullet into the game. And then we can shoot. Now it's currently set up that the health goes up if you shoot them, but your health goes down when you run into them. And if you're on the ground, we get the strobing background and health continues to go down. So we can see health is going down, collision side is none, is on ground is true. The unicorn X is here, the camera X and the game world X. Those are the numbers that we're looking at here. So part of it, you'll notice game world X never changes because it's always set up as that. The camera X we can see now is at 554. We're kind of almost halfway across the first image of Aaron Rodgers. And we can see the unicorn's X is at 900, but the camera's X is at 554. Remembering the camera is right in the top left corner of the screen. So firing timer controls how frequently we can shoot. We can tell our firing timer to start. Now the firing timer, once it fires, then that just keeps setting. It keeps automatically resetting itself, and we tell it to, hey, let's go again. But it doesn't actually fire the bullet. Firing the bullet is if we look at our key codes, our key press, key release, we have space going on there. So inside the draw function, there's a little segment called bullets. Inside the bullets, we can see that if space is true, then we say, hey, let me just fix the indents there. Then if the firing timer is complete, then we grab the next bullet in our bullet array, and we tell it to fire. We're going to pass in some information to it. And then we set the next bullet to be the next bullet in the array. And then we tell the firing timer to start again. So that's why we're able to, as we fire, we can limit how frequently we fire. Now the bullet is receiving, in its fire command, it's getting some position information. It's getting X and Y information. It's getting the width of the unicorn, and it's getting whether the unicorn is looking left or right, because the bullet doesn't start from the center of the unicorn. It comes out of its eye. It's kind of like the unicorn shooting laser beams out of its eyes. That's what it should be. Makes sense. So if I look at the bullet, when we choose fire, we're going to pass in these values, the unicorn's X and Y, the unicorn's width, and the unicorn's facing right property. Then we check to find out if the bullet is in motion. And if the bullet is not in motion, then we're going to set its in motion property to true. And if we look here, we go Y is equal to the unicorn's Y minus 3. Now the -3 is to pull it down from the top of that box so that it lines up with the eyeball. So if I look at the unicorn, and we look at this, the green box, if I don't have the -3, it's shooting it too low. It's kind of coming out of its nose then. And that just looks silly. Well, I guess you could work that into what you want. Then if we're facing right, we say our x velocity is going to be 15. And then we have to shift our x position to the side of the unicorn and adjust it over a little bit so that it comes out of the eyeball and is not coming out of, because we don't want it to start at the edge of the box. We need to come back 35. Because if we start out at the left edge of the box, then we go the width of the unicorn, come back 35, that allows the bullet to start right around the eyeball. Now these numbers were arrived at by keep changing the numbers until the laser beam seems to originate from the point that I want it to originate from. And that's where that comes from. Now, if we're not facing right, that means you're facing left. So then our Vx is a negative number because we want the bullets to go to the left. And then we set the position of the bullet equal to the position of the unicorn's green box, as we can see there. So that works out to be right at the corner of its eyes, so then that is fine. Now, the reason that we have this in motion part, we only update the position of the bullet if its in motion property is true. Otherwise, the bullet doesn't need to be animating on screen. So the bullet only applies Vx and Vy to itself if it's in motion. And the bullet only goes in motion when it's been fired. So the bullet updates its position if it's in motion. Then it checks, which these boundaries, I guess they could also be inside of in motion, doesn't really matter. But it checks, it sets a right boundary, sets a left boundary, an upper boundary, a lower boundary. And then if the bullet exceeds any one of those 4 boundaries, then it resets. Now, realistically, the bullets are shooting horizontally. So the top and bottom boundaries don't really matter because the unicorn can't fire outside of those bounds. But I put those in because some of you may make something where you're shooting up and down instead of left and right. So it's like, all right, fine. And if you'll notice, they're pretty much the same as the X values. The upper and lower boundary are the same as the X values. Now, it's using that max thing again. So the right boundary is either going to be the width of the camera or the position of the unicorn plus half of its width plus half of the camera's width. Now, how I arrived at these values was through a whole bunch of trial and error, whole bunch of putting in a bunch of different numbers and values going, because if I didn't do this, if I just said I can fire the width of my entire game world, I can now shoot things off screen. So if I can shoot all the bad guys off screen, I just have to stay on one side of the screen and just keep firing, spamming bullets, and then go across the screen and find everything's dead. And that was really lame. So it makes more sense that we can't fire beyond the edge of the screen. And that's what the left and right boundary are doing, is they're figuring out where are those values that we need to stop at. So to do that, I had to show myself what those values are. So this where it says BLB and BRB, that's the bullet left bound and bullet right bound. So I now had to set those values to figure out what are they. And I also then put up the unicorn's X, the camera's X, the game world's X, and started looking at, okay, well, what are the numbers showing up on screen so that what do I need that value to be? So if I look at, okay, the unicorn's X is at 871, the camera X is 521. Well, the camera X at 521 is the edge of my screen right here, so I know that that's where I want the bullet to stop. For the right boundary, I had to figure out, it was easy when out here, because then we know, I can just figure out with the camera's width of where it's going to be added to the camera's X. Okay, we're good. But the bigger issue is, okay, now I'm over here. Camera X is at 0. Because when the unicorn's in the middle of the screen, we really know that I only need the bullet to travel half of the camera's width beyond wherever the unicorn is. But when I'm all the way over here, I now need to go more than half of that distance. I'm almost going the full screen. So I now needed to figure out a different value. And that's where using that max value is, it's either I go the full width of the camera, or I go the unicorn's position plus half of his width plus half the camera width, and then that seemed to give me the value that I needed so that I was able to keep my bullets within the bounds of what is essentially the width of the camera. And doing that then allows me to then tell the bullet to reset once it goes off screen. When the bullet resets, puts itself back off screen, kills its velocity, and it's no longer in motion. So that took care of firing the bullets. Then we need to find out, does a bullet intersect with an enemy? So it's the same rectangle collisions, but instead of passing in the player versus the enemy, it passes in a bullet versus the enemy. So rectangle PVE, rectangle BVE, they're the same. Now, because they are essentially exactly the same code, it's really kind of sad that it's programmed this way. And there are ways that you can work around that. And what we would do if we were working around that is we would have objects being an extension of an existing class. So we would have, say, a collidable sprite, which would include players, enemies, and bullets, and they all are derived from the same class. So we're just passing in their parent object instead of having to pass in a bullet in an enemy or a player in an enemy and have two separate functions because we're passing in different values. We could just have one function that would take collidable sprite with collidable sprite. And then we could just pass that in and then it would work. But that's moving our coding into a next level of abstraction and complexity, and that's why I decided to have a repetitive function versus making it kind of get more complex. But that's where we would go to, because anytime you have code that repeats and you do the same thing twice, that tells you there's probably a better way to do it. So now the bullet checks to see has it collided with an enemy, and it checks to see if that enemy's dead, and if it's not, then it tells the enemy to death jump, resets that particular bullet, and then it, in this case, I gave back health. So if you shoot the enemies, you get health back. If you run into the enemies, you lose health. If you shoot the enemies, you get health back. That's fair. You will notice that this is a for loop inside of a for loop. So the outer loop is using I. The inner loop is using J. And at first this wasn't working, and I was confused as to what is going on and why are my bullets not firing correctly. And that's because I had I occurring in multiple places when it shouldn't have been. So it was like enemies I, and I forgot to change enemies to J, so then it wasn't B. I was like, what? This is wrong. But then it all got fixed once I got my I's and J's straightened out. So firing the bullets, checking to see if the bullets are colliding. Otherwise, the bullet is pretty similar to things that we've looked at before. Similar to an enemy, similar to the unicorn. So we kind of have static objects like the platforms and the background images and stuff like that. And then we have more dynamic objects like the enemy, the bullet, and the unicorn. So we start thinking about classes of objects being related to each other, and that's how we can start organizing things down the road in more advanced projects. But this allows us to fire. And I like that the enemy is short enough that I can't shoot it when I'm standing on its platform. I have to kind of be jumping. And we'll see that this platform up here that's a death platform. So let's see, that platform would be drawn at, I think, an X of something. So we can see that platform 6 has the death part put on it. That's why the unicorn turns red. Looks like that. Now, if you want your platforms to look different, you could set it up so under display, if type of, well, forgot parenthesis, type of is equal to safe, then we'll use that fill. Else, if type of is equal to death, we'll fill with green, because green is a toxic color. So we can now change the display based on the type of platform, so then it would you'd have that visual indicator beyond just what happens to the unicorn of what kind of platform is safe, what is dangerous. And this was part of why when the platforms originally were created, they had that type of property so we could change. And if I'm not changing the color, maybe I'm changing the image. So I have a different kind of image. I could have 2 or 3 different kinds of platforms with different kinds of images, and I display the correct image based on what type of platform it is. But a platform is just a platform as far as its X, Y, width, and height is concerned. So it doesn't make sense to make additional platform classes. We just have that property that changes how we look at it.